So let's go ahead and create the controller we're going to be using to handle all those movie related requests. And I'm going to start by simply going to the controllers folder in the API project and creating a movies controller. And now this controller, we need to have two things. The first thing is extend the controller base class. And the other thing is it should have an API controller attribute. Those things add functionality to the controller, and that's going to become way more apparent later, but for now, just leave it there. And since we now have registered that iMovie repository in our dependency injection, I can also inject the private read-only iMovie repository over here. And the way I can inject it is through the constructor. So I'm going to say constructor and then iMovie repository, and match it over here. So movie repository is this. So every action in my controller now will be using this movie repository to make all the necessary actions. So since we have that, let's go straight ahead and implement movie creation. So what did we learn in this section? Well, first we create our project and we structure the architecture of our code base to have the API, application, and contracts project separate from each other for better separation of concerns. Then we defined our API contracts and made a temporary in-memory database so we can implement our endpoints. Then we created all the CRUD aspects of the API, so create, read, update, and delete, and we perfected all of them. And then we introduced mapping and a dedicated space to store all the API endpoints. Now in the next section, let's go beyond basic CRUD and add some more complicated functionality to our API. Now, before I move forward and show you how to build the API, I want you to show you what we will be building, just to be excited about where we're heading. So the main domain we're going to be working with is movies. Think IMDb or Rotten Tomatoes. We're going to have a library of movies where we can actually list movies, create movies, update them or delete them, and also have users rate them, delete their ratings, or list all of their ratings. And if I want to list all the movies, then I can simply make that request and I can see all the movies I have in the system. You can see things like an ID, a friendly title, the actual title, rating, and my own user rating, and then the year of release, and also all the genres of that movie. If I want to get a specific movie, I will be able to use the ID of the movie or the resource in REST terms to get the item. And if that resource does not exist, then I will get a 404 as you'd expect. I can go ahead and I can create a movie if I want. So I'm going to go ahead and create Nick the Greek, and here you go. And then I'll be able to do things such as update or delete the movie. But what I want to do is actually rate the movie. So let's say I want to give this movie 5 stars. I'm going to go here and replace this ID with the movie rating, and I'm going to get 200. The movie was rated. So when I go back and I retrieve that movie over here, I'm going to see that both the movie rating and my rating is 5. As more users rate it, the rating will be adjusted to what the average of all the ratings is. Then, of course, I can delete a rating and I can list all the ratings. But this is our main domain, and this is a true REST API that we will be building. But before we get into this, which is ultimately the end goal that includes things like filtering, pagination, sorting, and all that good stuff, let's see how we can get there. And we're going to start by creating the project. One last thing I want to point out is that to make it easier for you to follow the course, I actually have this help us folder over here, which contains a Postman collection, which you can actually go in Postman if you're using Postman as well, and import here so you can have the same collection as I have over here with ratings, movies, and identity. And I also have a movies.json that has tons of movies over here, as you can see, that you can just copy and then use in the application as we go. So let's start by creating the project and the structure for our APIs. And we're going to use 3 main projects here, and I'm going to explain why. So I'm going to go into this getting started solution folder, and I'm going to go with a new project. And the first thing I'm going to do is select web application here, ASP.NET Core web application, and I'm going to choose type web API. No authentication, no nothing, just web API, C#. And I'm going to call this movies.api. And that is it. I'm going to go ahead and create that. Now, the next project I need is my application project, and that can be a simple library. So I'm going to say movies.application. The reason why I have this application layer is because all of my business and infrastructure logic will actually go in here. It's not going to go directly into the API. The API will be directly responsible for anything API specific. Things like authentication, authorization, documentation, health check endpoints. Those things are unique to the API. This means that I can actually use my existing business logic, my existing application project, and have a different way to interface it. For example, a UI, a Blazor application, an MVC application, maybe Razor Pages, maybe even something else. I'll be able to reuse that exact code, which is completely agnostic from the API layer that is consuming it. And the third project I need is actually the contracts project. This is another class library, and I'm going to say movies.contracts. And this is where I'm going to put all of my API contracts. The reason for that is because I can then go ahead and publish this as a NuGet package and give it to other members of the team or other users of the API and use those exact contracts and always be in sync with what contracts my API is exposing. And by contracts, I mean the request objects and the response objects. Now, there's a few things I want to do. First, in the API, I want to delete the weather forecast related controller and model, and I'm going to add a reference of the movies.application project on the API and also the contracts. So the API is using both the application layer and the contracts. The application itself doesn't know about the contracts and doesn't know about the API. This is very important. So now I have my structure. Since I know what my requests and my response will look like, I can take the next step to define my API contracts. So let's start with defining our requests and our response contracts. I'm going to go to the contracts project and create a new folder called requests. And then I'm going to go ahead and create another one called responses. My request folder will have all the incoming requests and response will have all the outbound responses. So the first contract I need is obviously creating a movie. So that will be called create movie request. And it's just a C# class. Now, what does that body look like? Well, we can actually go back to Swagger and see over here what the body looks like. I have a title, I have a year of release, and then I have an array of genres. And that is it. So first, I'm going to create my property, and I'm going to call that title. Then I'm going to create my year of release, so year of release. And then I'm going to have that array represented as a non-enumerable of strings called genres. Now, a few things I want to change here. These are all required properties. So I'm going to say required here, and required here. And these are also init only properties, so they cannot actually be changed. And I'm also going to set a default value for enumerable here. So I'm going to say enumerable.empty string enumerable, and that is it. And the great thing is that actually the next contract we need, which is update movie request, looks exactly the same. So we can copy all these properties and use them here as well. Now, why didn't we reuse the same contract for both requests? Well, that is because as we're developing the API, we might need to add properties in this object that shouldn't be in the update object, and vice versa. Update might have something more that the create movie request does not have. So you might not want to use the same contract because you might introduce some property that not both of them actually need. Obviously, once you publish your API, making such a change would break your contract. So you cannot really break your contract once published. But as we're working on it, we can choose to do that. So we have create and update. We don't really need a delete one because delete only depends on the identifier of the resource. So we can go to responses and create our first response, which is the movie response, the response representing the movie. And that can actually also share a lot of the objects of these items over here. So we're going to have the title, the year of release, and the genres. The main difference is that we also are going to have the ID of the resource. So GUID ID, and I'm going to turn this again into init only and required. If you're in the previous C# version, you don't need to use required on init. It is just a better practice to do that for contracts that are not supposed to change during runtime. So now we have that. And if you remember, what we can also have is not just a single movie as a response, but also a list of movies over here in the API movies endpoint. So what I'm going to do is go ahead and create a new object here called movies response. And I'm going to have enumerable of the movie response object. I'm going to call that items. And again, that will be init only, required, and default to empty. And that is it. Now we have the API contracts that our API will need to use. Now let's go to the API itself and introduce an in-memory fake database so we can start building our API. So now that we defined our API contracts, I can go ahead and create an in-memory representation of what my database will eventually look like and expose that in my application layer through a repository to allow me then to go to the API and implement my endpoints. And to do that, like I said, I'm going to use a repository pattern. So I'm going to say repositories over here and create a new folder. And then I'm going to create a new interface and call that iMovie repository. I'm also going to create an implementation for that repository, and I'm going to call that movie repository, and it will go ahead and implement iMovie repository. Now, in this repository, I need to define what the repository can actually do. And those actions are usually create, get all, update, and delete. But before I do that, I will need a model, a domain model. So I'm going to create a models folder and create in here a new movie object. Now, this object will be largely the same as our requests. However, it will have a few differences. First, it's going to have a required GUID because the ID of the movie is required and in it only it is immutable, it cannot change. It's going to have a required title, but this one has a setter because the title can actually change during the application's runtime. It is the same story with the year of release. You make a mistake, a movie is pushed back, and the year of release is now from 2022 to 2023. And in the end, I'm going to represent my genres as a list of strings in it only, but it's always defaulted to a new list and it is required. So you're going to have to specify them. And this approach actually allows me to also add items during runtime because this is a list. It is a mutable data structure. So with that in place, I can now define my repository interface. The first thing I need to do is create a movie, and we're going to use that contract over there. We're going to return true if it was created, false if it wasn't created. Then we're going to have our get method, so get by ID using the GUID, and it's a nullable movie because you might get it, you might not if it doesn't exist, and based on that, we're going to return 200 or 404. And we also have the IEnumerable over here for get all the movies async. We also have the update movie async. So if the movie was updated, then fine. If it wasn't, then false. And you're going to have to return an appropriate status code. And the last thing is delete by ID. Now, one thing I need to point out is that many people prefer to omit the by ID aspect because it is more often than not implied. I'm going to be leaving it here because we're going to see eventually how we're going to graduate to a structure that allows for more flexible retrieval of data. Now we can go to the movie repository and we can implement the missing members, which is all the methods defined in the interface. However, we're not going to store it in a real database like I said. We're going to use a private read-only list that stores movies. And that's basically our database. Just movies. We're going to initialize it to an empty one every time, and here we go. Now the implementation of those movies is pretty straightforward, so you're gonna have to say something like movies.add the movie in and just return task.fromResult true over here. And I should point out that we have them as tasks mainly because we're gonna eventually use a real database, and the real database will be asynchronous, so we're gonna be using our wait async here. So we're just kind of future-proofing this course material. Then to return a movie by ID, we're going to have a single or default check on the ID itself. And if it is there, we're going to get the movie. If not, because of the default check, we're actually going to get null here. Then to get all, we're going to simply return movies and cast it as an enumerable. And that is really it. Then update is a bit trickier because we need to find the index. And if the index is -1, it means that the item does not exist in our dataset. So we're going to return false. Otherwise, we're going to set it and return true. And the last thing is we're going to remove all matching that ID. And if the count is more than 0, so at least one item deleted, then we're going to say true, otherwise false. And that is it. Now, this is a repository that will be injected in our controller eventually, or our minimal API later down in this course. So we're going to have to register it. Now, to register it, we can go to program.cs, and we could say, if we wanted to, builder.services.add singleton iMovie repository, movie repository. However, this is actually not a great idea because the whole point of having this application layer is encapsulating that logic in that layer. So by just doing this here in the program.cs, it implies that every consumer should know how application concerns needs to be registered, which is not a good way of designing. What we're going to do instead is actually create our own extension method called add application over here. and we're going to implement that in the application layer. So I'm going to go ahead and create a new file, and I'm going to say application service collection extensions. And I'm going to turn this into a static class. And here's where it gets interesting. Like I said, applications should know nothing about how the system is consumed. So the fact that the API has dependency injection and the way it does that is not something that the application should really be aware of. However, Microsoft has provided this Microsoft.extensions.dependencyinjection.abstractions package, which only adds the abstractions of dependency injection. And given that everything in .NET is actually using the same interfaces, we can actually add this NuGet package in the application layer and be absolutely fine. So now we can say public static iService collection over here, and we can say add application this iService collection services. And then in this method, we can say services.add singleton movie repository, and then return the services. I should point out that I cannot materialize or build a service provider out of that services object. It is just the interface. I don't bring dependency injection in the application calls. I'm just bringing the abstractions. And now I can go to the program.cs and inject that method. And that is it. Now my registration is there. So with all that in place, let's go ahead and create what really handles our requests, and that is the controller. So how do we create a movie? Well, let's take a look at the call here in Postman. We have a post request at the /API/movies endpoint, and we have this request body over here, which we actually already have the object for. Now, if I go ahead and I send this, nothing happens because my API is not running. But when it actually runs, we're gonna need to handle this request. How do we do that? Well, let's start by actually adding a route parameter or attribute over here and saying API. The reason why I do that is because I have that API here as well. We could also add the movies part, so we can have the route be here and defined like this. However, truth to be told, I have found this system of splitting your routes very clunky and I don't prefer it. So for now, we're gonna leave this here, and in a second, we're gonna actually refactor it out of the system. But for now, let's have the API over here, and then let's go ahead and create our action. So we're gonna have a public async task that returns iAction result, which is the result that can represent any form of action from this action in our controller. And we're gonna say create over here. Now create needs to accept this request body. So how do we do that? Well, we're gonna say with an attribute from body create movie request. We're gonna name this request, and we're gonna import that from that contracts project over here. Now to actually route the request here, we're gonna use an HTTP post attribute, and we're gonna say movies. And that is it. What I can do is just return OK request, and OK actually is part of this controller base class we added previously. So if I just do this and I go ahead and I run the API, all that's really going to happen when I call this endpoint, and I'm going to put a breakpoint here, is my object over here will be mapped to that request. So as you can see, I hit the breakpoint and I can see in the request that I have all the genres here. So comedy, title is Nick the Greek, and year of release is 2023. So if I just let it run, I'm going to see that response in the response body. So title, year, genres, and OK. Now, of course, this is not what we want to do. We actually want to call the repository to handle the request. So we're going to do that. I'm going to say movie repository.create async. And what does this need? It needs a movie. Okay, so I'm going to create a movie object. So I'm going to say new movie, and that movie has some required parameters. So let's go ahead and create them here. First, we're going to have an ID. We're going to just generate that on the fly. Then we're going to have the title, which comes from the request. So title. Then we're going to have the year of release. So request.year of release. And then we're going to have the genres, which is request.genres.toList. And that is it. So now we have the movie object here, the domain object. We pass it down. We get the result, and then we await. Now, in this case, we actually don't care about the result because we assume it's going to be successful. If it's not, then an exception will happen. So I'm going to go ahead and return the movie we created. And that is it. I can now go and debug this. And if I go ahead and I just run this endpoint, as you can see now, we also get the ID because we now return the appropriate response object. However, this is not how a create endpoint in REST should return. It should not return OK when something was created. It should actually return 201. Let's change that. I'm going to go ahead and say here created. For now, we're going to be revisiting that. And I'm going to say URI, and I'm going to just create where this thing was created. So it will be in API movies and then / the ID of the movie. So movie.id, and then I'm going to return the movie object. And that is it. Now, if I go ahead and I debug this and I run it, and I go ahead and I do the same create request, then we're getting a 201 created, which is what we should be getting. And also now in the headers, you also have the location of where this item is using the location header. That's how it should be. Well, kind of. For now, we're going to leave this as it is, but we're going to revisit it in a few lectures to see how we can perfect it. But fundamentally, this is how you create a resource in a REST API. Now, let's see how we can improve on this. As you can see, we have the request here, which is an API contract, and we have this movie, which is a domain object. And we have this weird relationship where we are mapping that request to our domain object and then passing it down over here. And notice the word I used, mapping. We are converting from one object to the other. This process is very common in ASP.NET Core and APIs in general. And people tend to use packages to do that sort of thing, using things like AutoMapper or Mapster and so on. In my experience, you don't actually need any of that. And the reason for that is because mapping should be so simple that you don't need to resort to any third-party libraries. So what we're going to do instead is we're going to create a new directory, and I'm going to call that mapping. And in here, I'm going to create a new class called contract mapping. Now, this class will contain all my mapping related activities. So for example, in this case, I have the request to movie mapping. So I'm going to say public static, and yes, I'm going to turn the class into static as well, and say movie map to movie, and have this be an extension method of the create movie request over here. So I'm going to get a request and map it to a movie. So I'm going to copy all of that exactly as it is and paste it here and just return it. So now my mapping is removed and moved into a mapper without having it to bloat my main controller code. So now all I need to say is request.map to movie, and that is it. Way better code, and as we go, all our contract to domain and domain to contract mappings will go in here in the form of extension methods. You do not need libraries, you do not need AutoMapper, you do not need any of that. This is way more manageable and way more preferable. The most important thing that you need to know is you should not put business logic in here. This is very important. That's why it's static, that's why it's simple. Don't try to do fancy things in your mapper. Now let's go ahead and improve on this even more. Remember when I mentioned that I don't like this being split here and this being here as well, and then you have all these magic strings? Well, that's because I've seen this thing fail so many times. And there's actually a pretty simple solution for that problem. All we need to do is move all that in a central location. And that location will be a new class. And I'm going to call that API endpoints, or simple endpoints, depending on how you want to name your class. Now, this class will be a static class. And in here, I'm going to have a few very interesting things. First, I'm going to have a private constant string base. And this is the base of my API. So I'm just going to call it API because this is what the base of my API is. This API part is, by the way, optional. Not every API needs to have it. But in general, it is good to have it because it can be mapped in many ways. Load balancers can use it to exclude things. So it is not a bad idea to have it. And then I'm going to go ahead and create a public static class called movies. So a movies class in the API endpoints class. And I'm actually going to rename this to API base. And in the movies class, I'm going to create a new base over here called movies. So any resource in those movies will start with movies. Now I will need to also use the API base. So my base also includes the API base. So now everything is here. Since create is simple API and movies, all I need to say is public, and that's the first thing I'm exposing, public const string create. And the endpoint for that is just the base. So now all I need to do is delete that API route from here and delete this thing from here too, and say API endpoints.movies.create. It guides me to just hide those magic strings and have this thing here. And I could, by the way, as well say, for example, here, that yes, this is now the endpoint and I can reuse it without having to worry about it being out of sync. So every other endpoint we add in our API will be here and will be reused in that way. And of course, if I run this, as you can see, I can create a movie, no problem, the exact same way as before with the header and the body and everything. Now let's go ahead and implement movie retrieval. So now we need to get the movies we create. So the first thing I want to do is go to the API endpoint and create those two endpoints. So the first one is public const string, and I'm just gonna get, and get is get by ID. So I will say base / and then I'm gonna escape the angle brackets and I'm gonna say ID here. So accept the ID as a route parameter named ID. And then to get all of them, public const string get all equals base, because it's the same thing. What you can also do at this point is actually use a constraint on the route. So say :GUID, and this will only accept GUIDs as an ID, nothing else. So now with that in place, I'm gonna go and create my two endpoints, starting with the get by ID. So that is a HTTP get endpoint API endpoints.movies.get. I'm gonna say public async task I action result. All of them will be action result, and then get. And here I don't have a complex body. All I have is a route parameter. So I'm gonna say from route GUID ID over here, and then I'm gonna get the movie using the repository. So get by ID, pass down the ID, and then if movie is null, then we're gonna return not found, which is another method in that controller base that we're extending from. Otherwise, return OK, but we don't want to return the movie, the domain object itself. We don't want to expose that because the contracts are fixed, but domain objects can actually change in any way we want. So we're going to have to map it at this point. I'm going to go to the mapper and say public static movie response over here. And I'm going to say map to response. I'm going to say this movie, and I'm going to create a new movie response. I'm just going to map all the items the same way I mapped them before. Here we go. Having this layer is very important because it's a safety net between what us as a server and our consumers have agreed on, yes, that is the response object, that's how I'm responding, and any changes that we can have in the movie layer as we go later. So we're going to have that here, and now I can say movie.to or map to response. And that is it. I can even extract this to make it a bit more readable and say var response equals map to response, and then response over here. The next action I need is actually an HTTP get again, but it's an API endpoints movies.get all. Again, public async task I action result, but get all this time. And in this case, I have no parameters because I'm just getting all the movies in the system. So I'm just going to say var movies over here. And I'm going to use the movie repository to get all async. And again, I need to return them as OK, but actually I need to be a movies response, not a simple movie. So I'm going to say movies.map to response over here. Of course, I will have to implement it. So I'm going to go to the contract mapping and I'm going to say public static movies response is map to response. And then the extension point is this I enumerable of type movie. Here we go. So movies and return new movie response. And we're actually going to use the other mapper here. So we're going to say items is movies, and we're going to say select over here and reuse the map to response method. And this should be working. There's a good chance I have a typo in here. So let's go ahead. Yes, this should be movie response and this should be movie response. And now everything is working. So with that in place, let's go ahead and check those endpoints. So I should be able to create a movie, get all the movies and get a movie by ID. Let's get all the movies, which should be nothing currently in the database because every time I restart, I get a new fresh database. So items are empty, 200, great. Now let's try to get a movie by ID that surely doesn't exist. Not found, great. And let's go ahead and create a movie. So I'm going to create the movie. And movie was created. I'm going to get the ID. So as you can see now, if I get to all movies, I get all the movies. And if I try to retrieve a movie by ID, as you can see, I'm getting the movie. Perfect. Now that we have these get endpoints, we can actually absolutely perfect that original create endpoint, because there's one way to make it even better. Let's take a look at that. So what is wrong with this create endpoint? Well, technically nothing is really wrong. However, it could be a lot better. For example, if I go here in the post endpoint and I show you the headers, the response headers over here, we have this API movies create link, but this is generated in a bit of a janky way. I have to know what the route is and then concatenate the string, and then it is not amazing. And actually, ASP.NET Core has a great solution to this. I can actually say return created at action, and I can point to the action name. So I can say get, for example, because this is created at the get endpoint of this controller. And if I want to override the controller, I can. There is actually an override, but I don't need to. All I need to do is point to the action, and to be safe, I'm going to use the name of parameter. So name of the action is get, and then I'm going to pass down the route parameter as an object. So I'm going to say id equals movie.id, and then pass down the movie itself. And that way I can just delete everything and I can rerun the API. And now if I go to Postman and create this movie, as you're gonna see over here, I have the full contextual location of the item. I can just copy that, go here, paste it, and it will give me the link. No matter what the route of that endpoint is, it will find it based on the action programmatically and dynamically. It is excellent and you should be using it. It just makes life with location headers so much easier. Now with that in place, let's go ahead and implement updating a movie. So let's go ahead and implement movie update, which is a bit more interesting because it actually has two components. It has both a request body and the route parameter, because when you update, you point to the resource you're routing to or that you're updating. So I'm gonna go to the API endpoint and I'm gonna go ahead and copy get and paste it here and rename it as update, because the endpoint will look the same. We have the GUID as an ID parameter over here in the endpoint. And then I'm gonna go down here and say HTTP put. We're gonna do a full update and say API endpoints.movie.update. And I'm gonna have another public async task action result over here with the update name. And I'm gonna have two things over here. First, I'm gonna have the from route GUID ID, and I'm also gonna have the from body update movie request. So to update, first I will need to map the request to the movie. So I'm gonna say update movie request.map to movie, and to do that I will need to create a new contract mapping over here. I'm just gonna copy the create movie request and update it to say update movie request, but I'm not touching that ID because I'm not updating that ID. Instead, what I'm going to do is add it as a parameter. So I'm going to say pass down the ID since it is init only. And then in here, I can say ID, and I'm going to get the movie mapped, the new domain object. And then I'm going to call the repository and say updated equals await movie repository dot update async, and pass down the movie object. And if it wasn't updated, mainly because it didn't exist, then I'm going to say return not found, because it wasn't found to be updated. Otherwise, I'm going to have a response and say movie.map to response, and then return OK response. Here you go. That is it. So now let's run it and see how it works. I'm going to go first in here and create the movie, because every time we refresh, we lose all that data. So Nick the Greek now exists. I'm going to copy the ID, go to the update movie endpoint, paste this over here, and I'm going to update this to be both a comedy and an action movie, while currently, as you can see over here, it is only a comedy. So I'm going to go here and just say update, and the movie has in fact been updated with the action and the comedy. And if I go to get all, as you can see, I have both items here. And again, if this wasn't something that existed in the database, I can say send, and I'm getting a 404 not found. So we're implementing everything that the REST API should implement. And the last thing that we need here is the delete movies endpoint. Let's go ahead and do that. So the last thing we need for our REST API is to implement that delete endpoint. So I'm going to go all the way at the bottom and create and say HTTP delete, because that's how we define a delete endpoint, and say API endpoints.movies.delete, and go ahead and create that API endpoint. It's the same structure as get and update. So I'm going to say delete over here, And then I'm going to create my public async task of iActionResult delete. And all I have in the request is actually that route parameter. So from route GUID ID. The body is dead simple. All I'm going to say is var deleted equals await movie repository dot delete by ID and pass down the ID. If it wasn't deleted, then it didn't exist. So return not found. If it was deleted, then return OK. And that is really it. I'm going to go ahead and just run this just to show you all the CRUD aspects, create, read, update, and delete of our REST API come together. So I'm going to create my API first. As you can see, it was created. I can get a movie by ID. I can list all the movies. I can update a movie. And in the end, I can just delete that movie. And as you can see over here, the movie no longer exists. And if I try to redelete one that doesn't exist, I'm going to get a 404 not found. So that covers all the actions a REST API can have except for one, and that is patch. Let's talk about patch for a second. So where is patch? Where are those methods that allow you to do partial updates? Well, patch has really fallen out of favor, and the reason for that is mainly because of how complex it is to build the request and process the patch request. It is very complicated. It is way simpler for a client to use the get endpoint, get the item they want to mutate, change it, and then send the whole thing for a total replacement through put. A patch body would look something like this. Every item you want to have, every operation would actually be a separate item in an array, and you would say that the operation is replace the name to the value greenhouse. You have to have a path to the item, or add, and we want to add the values name and color, so bedroom and blue. Constructing that on the client is very complicating. Handling it on the server is also very complicated because I have to make a method generic enough to translate every sort of mutation you want to make and convert that into effectively what is a database request eventually. So it is incredibly hard, and we don't really use them. That's why we're not going to cover it. Getting an item, mutating it, and sending it for a total update is just way more ergonomic, way easier for the developer. So we just don't do that. So with all that said, let's go ahead and recap this section.